Okay guys, so now we're on 10.1 and this is called conics. Congratulations, 10.1 is almost done. All you guys have to do is use your textbooks to define those vocabulary. Now, even though you guys are defining parabola, oh yeah, I'm sorry, I thought this is a hyperbola. But so these are the conics that we are going to study this year. We are not going to study hyperbolas, okay? We just don't have time for that this year. Now, in 10.2, I would also like you to use your textbook and find the definition of those as well. Now, once you guys are done with the definition, please try to read over example 1 and see if you can complete this example on your own. Okay. If you are done with it, you can come back later to check your answers. But now I will start lecturing this part right here. Equations of parabola. The vertex at h, k and axis of symmetry parallel to a coordinate axis when a is bigger than 0. So that means when a is positive, okay? So all of your vertex, all of these forms right here, we will always use h, k as a vertex. Okay, now you will have a focus. The focus is going to be h plus a, k. You will have a directrix, x equals h minus a. And remember, it will make more sense if you guys do the vocabulary and the example above, okay? Your equation for the parabola is going to be y minus k quantity square equals 4 times a times the quantity x minus h. Now, because it's y square, it's going to, this is called axis of symmetry. AOS is axis of symmetry, is parallel to the x-axis. And it opens to the right. Oops. Okay. Next one, we will have the equation of y minus k quantity square, and we will have negative 4a, and we have x minus h here. Now this, because it's negative, it opens to the left. Opens to the left, okay? And the axis of symmetry, it's still going to be parallel to the x-axis. Now, we are going to have the focus as at h minus a, k, and the directrix will be x equals h plus a. Next one, we will have something that opens up, which you guys already know how to graph. Opens up, meaning that the x will be square. So x minus h quantity square equals 4 times a, so that's positive. That's why it opens up, times the quantity of y minus k. Now the axis of symmetry, it's parallel to the y-axis. Okay, and again, make sure you guys define the vocabulary above on the prior page before copying this down. And try example number 1. Now your focus will be h, k plus a. And the directrix will be y equals k minus a. You will also have a parabola that can open downward. Okay, now the axis of symmetry is still going to be parallel to the y-axis. The equation is slightly different. It's just going to be a minus instead of a plus. So this is minus 4a times the quantity of y minus k. Now your focus is still h, but it's going to be k minus a. and the directrix will be y equals k plus a. Now that you have written that box down, let's go and check to see if you guys did example 1a correctly. Okay. Find an equation of the parabola with the given information. Find 2 points that define the lattice rectum. Graph the equation by hand and label the directrix, axis of symmetry, and lattice rectum. So they gave you a vertex at 4, -2. So let's go make some tick marks over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, I'm gonna get a different color pen since I already used that black one for tick marks. Okay, let's plot the vertex first. Vertex is 4, -2. So 1, 2, 3, 4, -2. So here's the vertex. Okay, and they gave us a focus. So let's label it V, and they gave us a focus at 6, -2. So focus is 6, -2. Okay, and remember, if you guys already copied down the definition of all of these vocabulary up here, then you should know the focus is always inside of the graph, meaning that because a focus is on the right side of the vertex, we know this opens to the right. Okay, so we know it opens to the right due to the fact that the focus is on the right side. Okay. Now, the focus and the directrix, it's exactly the same distance from the vertex. So what I mean is that this is a unit of 2. So that means the directrix is right behind it, 2 units behind the vertex. So if we count backwards 2 units, this is the directrix, okay? And we want to label it. And yes, directrix is a line, and we will label this line as x equals to 2. Okay, remember it says label directrix, axis of symmetry, and lattice rectum. Now, the axis of symmetry is right in the middle of your parabola. So that means it runs through the vertex and the focus. Okay, so this is your axis of symmetry, and this line is y equals -2. We have to label everything. Okay, so check that, check that. So what are we going to do here? How are we going to write this equation? Okay, now you guys know that this opens to the right. So if we look back here, if it opens to the right, we are going to use this equation right here. Okay, let's copy that down. And guys, when you guys are taking notes and doing your homework, just copy the formula or the equations down. So that way, by the time that you guys are taking your test, it's already in your memory, in your brain, okay? Okay, let's fill in the h and the k. Your h is going to be 4, your k is going to be -2. So y negative and a -2 is down to y plus 2. That's the k equals 4 times a. And then h is going to be -4. So right now, that's all we have. Okay, so now we have to find that a value. Remember we were talking about the distance between the vertex and the focus? That distance is actually an a distance. Okay, so that distance right there is an a distance. So from the directrix to the focus is 2 times a distance. Okay, so we know a equals 2. So what do we have? We got y plus 2 quantity squared equals 4 times 2 times x minus 4. So we are ready to finalize our equation, and that's 8 times x minus 4. Let's box that up. Now, what is 8? 8 represents the total length of the lattice rectum, okay? So lattice rectum length, it's 8 units. And what does that do? Let me tell you what that would do for us. 8 units is the total distance for the graph, okay? So that means half of it from the focus. So remember, this is from the focus. Lattice rectum, it's going to be perpendicular to the axis of symmetry. So because I have the lattice rectum length is 8 units, I'm going to go up from the focus 4 units, just like that, and down from the focus 4 units. And that will allow me, make sure I'm counting for 1, 2, 3. Yep, that's 4. 4 and up 1, 2, 3, 4. Oh, I'm short. 1, 2. No, 1, 2, 3, 4. No, the first one is right. My bad. Okay, so now it allows me to have 2 more points to graph the parabola, just like that. So we are graphing the parabola simply using the vertex and the 2 points of the lattice rectum. Okay, so lattice rectum points, because it says here, find 2 points that define the lattice rectum, and we have them both. So the 2 points, L, R points, okay? 2 points are from the focus. We know the focus started at 6, so both of them were still going to have 6 for the x-axis. We know the total length of the lattice rectum is 4, so we take the y value of the focus and we add 4 and we subtract 4. So if we add 4, we have 2, and if we subtract 4, we are going to have -6. So those are the 2 points that will define the lattice rectum. We already have the axis of symmetry label. Well, let's write it right here. Axis of symmetry, y equals -2. And we have the directrix. It's already on the graph, but let's just label it right here so we can have it all in one spot. Okay, so hopefully you guys got the same exact thing that I have here. Okay, so now hopefully that connects and it makes sense with the chart. Let's try B, okay? On B, I'm giving you guys the focus, which is -1, 2, and the directrix at x equals to 3. So the first thing you always want to do is to do a little sketch of that. Why do I need that? Okay, so let's make some tick marks. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Let's plot. Ready? Focus is -1 and then up 2. I'm going to use F for focus so I know what it is. Then the directrix is x equals to 3. 1, 2, 3. So here is the directrix. Remember, the directrix and the focus, directrix. Okay. So in the middle of the focus and the directrix should be your vertex. Okay, so let's find the distance right in the middle. So this right here is right in the middle, which is your vertex, which we have, that is 1, 2. Let's write that down. Vertex is 1, 2. Now we know since the focus is on the left-hand side of the vertex, we know it opens to the left. Okay, then if it opens to the left, let's go and see if we can write down the formula. The formula is going to be y minus quantity, y minus k squared equals -4 times a times x minus h. Now let's find what a is. Remember, a is the distance between the focus and the vertex, or the vertex and the directrix, okay? And it looks like it's 2 units. So this here is 2 units. So a equals 2. So with that, we can quickly write an equation. Y minus k is 2. So that's going to be -2 squared equals -4 times 2. I'm just going to write straight up 8, okay? Times x minus 1. Let's box it up. That is our final equation. Now we will define the lattice rectum length, LR. The length is going to be 8 units, okay? 8 units. And how do I know it's 8 units? It's always this right here, okay? The lattice rectum is always the absolute value of 4 times A. So this is going to be your lattice rectum. Now, because I do know it's 8 units, let's go and finish graphing it. That means I'm going to go up 4 units from the focus. 1, 2, 3, and 4. I'm going to go a little bit above there. 1, 2, 3, and 4. With the dot, I can now sketch out my graph just like that. If you miss your dot there, just make it fatter. Now we will also find the directrix, or label the, axis of symmetry. Okay, AOS, which is now y equals to 2. Y equals to 2. Okay, let's write in here. AOS y equals to 2, box that up. What else are we missing? The 2 points of the lattice rectum. And we can simply just look at the graph, or we know the 2 points for lattice rectum. We know the focus has an x-axis at -1. So we both know both of those are going to be -1. Now the lattice rectum length is 8, so that means we're going to add 4 and subtract 4 from the focus y-coordinate. So if I add 4, that's 6. If I minus 4, that's -2. And then box that up. Bam, just like that. Let's try one more right here, okay? So for this one, it says the vertex is at 0, 0. So let me make some tick marks. I'm going to get it black to make tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so let's plot the vertex right away. 0, 0. Let's label it V. And they gave us the axis of symmetry of the the x-axis. Okay, so that's right on the x-axis. Okay. Oh, where did that go? There you go. So right here is AOS. AOS. Okay, what else did it give us? And it contains a point 2, 3. So when you see the contains a point, that means 2, 3 is going to be on the graph. So let's plot that point. 2 up 3. So it's on that curve. Okay. We don't know where the focus is. We don't know how far the lattice rectum is. So let's go and figure this out. We know if the vertex is at the origin and there's a point on the right side, we at least know it opens to the right, okay? Then we know at least if it opens right, the focus, okay, it's a unit from the vertex. So that means whatever h is, we could add a, and k should be the same. Well, what else do we know? We also know the directrix is behind it, right? So directrix is going to be x equals h minus a. We need to figure out this a value really bad, don't we? All right, so let's write down the equation. We know it opens right, so let's just write down the formula first. So it's in our brain, okay, just like that. Well, h and k are both 0. So that means this is y squared, 4 times a, and then just times x. Well, let's find a. They gave us a point, 2, 3. So let's plug that in. 3 is y, so that's 3 squared equals 4 times a, and 2 is x, so this is 9 equals 8a. Divide both sides by 8, so a equals 9 over 8. Okay. Not a friendly number, but that doesn't mean it's not a number. So let's go and fill in our focus. So focus will be now h plus a. H is 0, so that's going to be 9/8, 0. Let's go plot that. Okay, 9/8 is just slightly over 1. Bam, just like that, focus. Okay, then the directrix is just simply h minus a. Well, h is again 0 because the vertex is at the origin, so this is -9/8. All right, box that up. So I'm going to go behind and just a tad bit to the left of -1. I'm going to write directrix. And I'm going to write x equals -9/8. All right, what I'm missing is actually my total length of the lattice rectum, okay? Total length is absolute value of 4a, 4a. And we see that a is 9/8. So that's going to be 4 times 9/8. That will give us a total distance, let's reduce, so 9/2 units. So that means it's 4.5 units, okay? That means I'm going to go up from the focus half of 9/2. So that's 9.25. Okay, so 9.25 is what I'm going to go up by. So that's going to be, so 9.25. Okay, so that's 2 1/4. So let's go up 2 1/4 from the focus and go down 2 1/4 from the focus and connect dots. Now, if they already gave you 1 extra point, technically, can you graph using that, reflect on the other side, using that 1 extra point that they had? Of course, but that's not the length of the lattice rectum, so make sure you're super mindful, okay? They do want us to get 2 lattice rectum points, so we are going to use the focus. The x will be the same as the focus x, so both of them will have 9/8. Now all we have to do is add 2 1/4 from the y coordinate of the focus and subtract 2 1/4 from the y coordinate of the vertex. Well, I'm sorry, from the focus. Okay, add and subtract 2 1/4 from the focus. So while the focus is at 0, the y coordinate, so what that's going to happen is negative 2 1/4 and a positive 2 1/4. So those are our 2 points for the lattice rectum. Okay, so make sure we have our equation box up, which we don't. Let's go and take this down here. Y squared equals 4 times a was 9/8 x, and so that's y squared equals 9/2x, and box that up just like that. Okay, and that's it, guys.